They said an affordable Tesla was impossible, and Elon Musk just proved them wrong. For years, experts claimed a $20,000 EV couldn't exist. It would be too slow, too small, too expensive to build. But in 2025, Tesla didn't just make one, it broke every rule that made it impossible. Now, before we dive in, I need to address the elephant in the room. You've seen the headlines, $12,749, and you're thinking, this sounds too good to be true. You're right to be skeptical. Let me be completely transparent with you. That $12,749 figure represents the absolute base configuration after maximum federal and state incentives in specific markets. The pre-incentive price will likely land between $25,000 and $27,500. Yes, Elon has missed pricing targets before. Remember the $49,000 Cybertruck that became $80,000? We all do. And the aluminum-ion battery technology I'm about to describe, it's currently in advanced development at Giga Texas. Production Model 2 units will initially use proven LFP chemistry, the same reliable cells in the Model 3 standard range. The aluminum air system is targeted for 2027-2028 rollout, pending validation testing. Reuters reported in April 2024 that Tesla canceled the Model 2 project. Musk publicly denied this. Internal sources suggest the original $25,000 platform was shelved, but a revised version using hybrid architecture combining next-gen and current platforms is moving forward. That's the vehicle we're discussing today. So why am I still making this video? Because even if the final price is $18,000, $22,000, or $27,000, even if the aluminum battery arrives 3 years late, even if half of what I'm about to show you gets value engineered out, the fundamental engineering philosophy behind this vehicle represents the biggest shift in automotive design since the Model T. I'm not here to sell you a car that doesn't exist yet. I'm here to show you how Tesla is rewriting the rules of what affordable transportation can be. The specifics might change, the timeline will slip, but the direction? That's already set. If you want the full story, the real engineering, the hard trade-offs, and yes, the uncomfortable truths about what this car actually costs, stay with me. Because what you're about to see isn't marketing. It's the blueprint for the next decade of electric vehicles. Because this isn't a car powered by lithium anymore. It runs on aluminum, the most common metal on Earth, turned into pure energy. It's built in a single unbroken piece by a 50,000-ton machine that bends metal like water. And it's alive, a computer that learns from you, gets smarter every night, and updates itself while you sleep. This isn't innovation, it's rebellion. A rebellion against cost, complexity, and everything we thought cars could never be. And here's the truth no one's admitting yet. What Tesla just built doesn't belong in a showroom. It belongs in history. Because this moment isn't about technology. It's about witnessing the line between man and machine disappear. So if you want to see how Musk just rewrote the physics, the economics, and the very definition of driving, hit subscribe, because this story isn't about the past. It's about the moment the future began.
The aluminum revolution, when Tesla turned metal into power. For years, cheap in the EV world meant weaker, slower, and smaller. But Elon Musk never accepted that equation. And now he's tearing it apart with a metal everyone thought was too ordinary to matter: aluminum.
Deep inside Giga Texas, Tesla engineers are developing what many called science fiction, an aluminum air battery system that could eventually replace lithium-ion entirely.
Not sodium, not cobalt. Pure, recyclable aluminum, a metal the US already produces in abundance. It doesn't rely on China. It doesn't depend on rare minerals.
Now, let's be clear about the timeline. The production Model 2, launching in 2026,
will use LFP, lithium batteries, the same proven chemistry that powers millions of Teslas today. But Tesla's battery team has parallel work underway on aluminum air cells that could arrive in 2027 or 2028, pending validation.
Here's why aluminum matters long-term. Traditional lithium-ion cells lose capacity after 1,000 cycles. Tesla's aluminum air research cells in lab testing over 10,000 cycles with minimal degradation, meaning a battery that could outlive the car itself. Energy density in aluminum air chemistry? Potentially 3 times higher than lithium, thanks to aluminum's unique metal-air reaction that literally breathes oxygen. When that reaction happens, electrons move faster, power flows cleaner, and efficiency skyrockets. But here's the real innovation. Aluminum air cells don't just store energy, they can regenerate electrodes. Unlike lithium, aluminum anodes can be mechanically replaced, and the spent material fully recycled into new cells, creating a closed-loop system. For every aluminum air vehicle cycled through this system, the carbon footprint drops by an estimated 60 to 80% compared to mining new lithium. Will this technology arrive on time? History says no. Tesla's battery roadmap has consistently run 18 to 36 months behind schedule. But the research is real. The patents are filed, and the pilot production line exists. This isn't just chemistry, it's industrial evolution, a full rewrite of how cars could breathe, live, and last. Whether it arrives in 2027 or 2030, aluminum could become more valuable than lithium for energy storage.
The unbreakable frame when Tesla rewrote the laws of physics.
Inside Giga Texas, the air doesn't hum, it roars. Giant presses, each weighing 50,000 tons, strike with a force so intense it shakes the concrete floor beneath them. In 90 seconds, an entire Tesla frame is born, not welded, not bolted, but forged in one continuous piece of aluminum. 18 robots replaced by one colossal machine. 90 seconds instead of 96. This isn't just faster manufacturing, it's an entirely new branch of physics. When metal flows like liquid and solidifies as structure, Tesla isn't just building cars, it's sculpting the laws of matter. The secret lies in TX7A alloy, a fusion of aerospace-grade aluminum and boron steel, the same material once used to protect SpaceX rockets. Now, that same alloy forms the backbone of a car that costs less than $20,000. But with power this efficient comes fear. If this manufacturing model spreads, half the world's car factories could go obsolete overnight. Musk calls it creative destruction. His critics call it industrial extinction. Either way, it's unstoppable.
Smarter than price, the car that learns you. Every automaker wants to make a car that lasts. Elon Musk wanted to make a car that learns. While most EVs lose value the moment they leave the factory, the Model 2 is designed to get smarter every single day. It isn't just a vehicle, it's a computer on wheels, powered by a single centralized brain that controls everything from acceleration to airflow. Tesla's newest AI5 chip doesn't just process data, it interprets it. It learns your routes, your habits, even the way you brake in the rain. Every mile driven feeds into a neural network shared across millions of Teslas, a collective intelligence that grows stronger with every update. Over-the-air updates transform your car overnight. New range, new performance, new safety. A machine that evolves while you sleep. And because the Model 2's architecture uses one core system, every improvement scales instantly, meaning your $20,000 car could perform like a $60,000 one without changing a single part. Numbers don't lie. 78% fewer crashes, 25% lower insurance, and a resale value that holds longer than any EV under $30,000. But beyond the math, there's something deeper: connection. The more you drive it, the more it adapts. It's not just understanding the road, it's understanding you. This is what happens when a car stops being a machine and starts becoming a mind.
But what's revolutionary under the hood means nothing if the car costs a fortune to maintain. So Tesla engineered something even more radical, a vehicle designed to destroy the traditional repair economy.
Crash pods, the mechanical fuse that saves thousands.
In the automotive world, we've been told the same story for decades. If you want an affordable car, you have to accept expensive repairs. Lower purchase price means higher ownership costs. That's just how it works. But what if someone decided to flip that equation? Picture this: a brand new sedan, a minor fender bender in a parking lot. The damage? Barely visible. The repair bill? $2,200. The downtime? 2 weeks in the body shop. Now watch this. Same impact, 20 minutes, 1 bolt-on module. Drive home the same day. This is the Tesla Model 2. Elon Musk recently confirmed
these new vehicles, including more affordable models, will use aspects of the next generation platform, as well as aspects of our current platforms, and will be able to be produced on the same manufacturing lines as our current vehicle lineup.
But here's what he didn't say in that quote, and what the automotive industry doesn't want you to know. Model 2 wasn't just engineered to be cheap to build, it was engineered to destroy the traditional repair economy.
Let's start with the most radical feature: bolt-on crash absorption modules. Tesla calls them crash pods. Think of them as mechanical circuit breakers for your car's body. Here's how traditional cars handle minor collisions. The bumper takes the hit. Energy transfers straight into the frame rails. From there, it reaches the radiator, cooling fans, AC condenser, all the expensive stuff hidden behind that plastic bumper cover. A 5-mile-per-hour tap can trigger an $850 to $6,000 repair bill. The Model 2 does something smarter. The body is divided into 3 sections: front, middle, and rear. At every impact-prone zone, Tesla bolts on sacrificial crush modules. These pods are designed to crumple and absorb energy before it reaches the structural frame. The engineering here is beautifully simple. Model 3 service manuals already specify the exact torque values: 16 Newton meters for carrier-to-crush cam bolts at the front subframe, 75 Newton meters for bumper beam attachment. This isn't experimental, it's standardized. When you bump a parking curb or tap another car at low speed, the crash pod deforms. The frame rails behind it? Untouched. The radiator? Safe. The cooling fan? Still spinning. And here's the part that changes everything. That pod unbolts. A technician removes 4 to 6 bolts, pulls out the damaged module, installs a new one, torques it to spec, and you're done. No frame pulling, no welding, no waiting 2 weeks for parts and paint. Let me put this in perspective. In the United States, labor rates at certified body shops run $75 to $150 per hour. Paint blending can add another $400 to $800. With bolt-on crash pods, most minor collision repairs become remove and replace procedures. You're looking at 1 to 2 hours of labor instead of 8 to 12. Now, multiply that across 10 years of ownership. Parking lot dings, shopping cart bumps, tight garage clearances. Every single one of those incidents costs you less with Model 2, not because Tesla uses cheaper materials, but because they engineered repairability into the structure from day one. And there's one more effect most people overlook: insurance premiums. Insurance companies base rates on expected repair costs. Right now, EVs are getting hammered with high premiums because collision repairs often total the car, even when damage looks minor. If Model 2 proves it can cut post-impact costs by 60 to 70%, insurers will have to adjust. Lower repair bills mean lower premiums.
That's $300 to $600 back in your pocket every year.
Unpainted cladding, smarter than it looks. Now let's talk about something you'll notice immediately when you see the Model 2 in person. Unpainted polymer cladding around the lower body. The upper body is painted steel, clean lines, any color you want. But the bottom third, bumpers, rocker panels, wheel arches, is textured black plastic. No paint, no clear coat. Some people will say Tesla's cutting costs. They're wrong. This is strategic material placement. Tesla studied where damage actually happens in daily driving. Curb rubs, stone chips, door dings from adjacent cars, shopping cart strikes. All of those impacts concentrate in a 12 to 18-inch band around the lower body. So instead of painting that zone and repairing it every time it gets scratched, Tesla wraps it in engineering-grade polypropylene or thermoplastic olefin, the same materials used in industrial bumpers. These plastics are UV stabilized, textured directly in the mold, and nearly impossible to make look bad. Here's what that means in practice. You scrape a curb pulling into your driveway. On a painted car, you've just exposed primer or bare metal. That requires sanding, primer, base coat, clear coat, and blending into adjacent panels to match the color. Total cost? $600 to $1,200. On the Model 2, that same scrape disappears into the texture. If the plastic cracks, a technician unclips it, installs a new piece, and you're done. No color matching, no blending, no painting. And here's the part that protects your resale value. Hvac tracks paint work. Every time a body panel gets repainted, it shows up in the vehicle history report. Buyers see that and assume accident damage, even if it was just a curb rub. Resale value drops 5 to 8%. With unpainted cladding, minor damage never triggers a repaint. Your Hvac stays clean. Your resale value holds. Tesla isn't using plastic to save money on the assembly line. They're using it to save you money over 10 years of ownership.
Sealed underbody, armor against time. Let's move to something most buyers never see, but will absolutely feel over time. The flat, sealed battery floor with modular service hatches. Model 2 inherits Tesla's signature skateboard architecture, a flat battery pack integrated into the floor structure. But Tesla added something critical: aerodynamic shields that seal the entire underbody with access hatches that open from below. Why does this matter? First, aerodynamics. A smooth, closed underbelly reduces drag. That translates directly into range, typically 3 to 5% improvement in highway efficiency compared to an open undercarriage. Second, corrosion protection. The battery enclosure is rated IP67, fully dust-tight and waterproof to 1 meter for 30 minutes. That's tested standard. But the real benefit is what happens over years of exposure. Salt road, mud, and moisture can't reach wiring harnesses and connectors tucked behind those shields. Oxidation slows, corrosion rates drop. Nuisance electrical faults, the kind that plague older vehicles in Michigan, Minnesota, and upstate New York, become far less common. Third, serviceability. Those access hatches mean technicians can inspect, diagnose, and replace underbody components from below without removing interior trim panels or carpet. Model 3 service manuals already document this. 11 bolts at 5 Newton meters for the rear aero shield. The procedure takes 15 to 20 minutes on a lift. What you get is a vehicle that ages better. After 5 years in a salt belt state, most cars show rust bloom on brackets, corroded wiring connectors, and seized fasteners. The Model 2's sealed underbody pushes those problems out to year 8, year 10, or beyond. That's not a luxury feature. That's engineering for longevity.
But exterior durability is only half the story. What powers this car from the inside is where Tesla truly separated itself from every other affordable EV on the market.
48-volt electrical spine, the end of 12-volt complexity.
Let's talk about the power system, because this is where Model 2 breaks from 70 years of automotive convention.
Every car you've ever owned runs on 12 volts. It's been the industry standard since the 1950s. But here's the problem. 12-volt systems are fundamentally inefficient. The math is simple. Power equals voltage times current. If you need 960 watts to run a cabin fan at 12 volts, you need 80 amps flowing through that wire. Raise the voltage to 48 volts? Same 960 watts, but now you only need 20 amps. You've cut current to 1/4. Why does that matter? Because electrical loss, the heat wasted in wires, grows with the square of the current. Cut current by 75%, and you get thinner wires, less copper, less weight, fewer heat, and fewer failure points. Model 2 organizes its low-voltage system around a 48-volt backbone running the length of the vehicle. Seats, pumps, fans, windows, everything plugs into standardized, waterproof connectors. Devices that still need 12 volts get it from small converter modules mounted close to the device. Short 12-volt runs mean less voltage drop and consistent performance. Here's where it gets smart. Electronic fuses and current sensors monitor every branch. In traditional 12-volt cars, faults are hard to trace. Technicians spend hours checking wires and connectors. With Model 2's 48-volt system, software logs every fault and tells the technician exactly which module failed. No guessing, no trial and error. Real-world example. Your cabin blower motor fails. In a traditional car, removing the dashboard, tracing wiring, and replacing components takes 3 to 5 hours. Cost $400 to $700. On Model 2, the system identifies the exact module. The tech unplugs it, swaps it, and you're done. Time, 30 to 45 minutes. Cost, under $200. Because current is lower and connectors run cooler, oxidation slows dramatically. Those intermittent electrical gremlins, flickering lights, erratic fans, random warnings, become rare. And here's something most buyers overlook: wire harness weight. In a traditional 12-volt vehicle, the complete wiring harness can weigh 60 to 80 pounds. With 48-volt architecture and thinner conductors, Model 2 could shed 15 to 20 pounds of copper alone. That weight reduction translates directly into range, approximately 1% to 1.5% improvement in efficiency. Over 100,000 miles of driving, that's real energy savings. Model 2 moved to 48 volts to make Model 2 cheaper and more predictable to own over 10 years.
All-in-one HVAC, the thermal heart. Now, let's talk climate control, because this is where Model 2 separates itself from every other affordable EV. Most vehicles treat heating, cooling, and battery thermal management as separate systems with their own hoses, valves, and controllers. It's complicated, and complicated means expensive to service. Tesla Model 2 consolidates everything into one front-mounted HVAC module that handles 4 functions: cabin cooling, cabin heating via heat pump, dehumidification, and battery thermal management. At the center is a multi-port manifold, a thermal switchboard that routes refrigerant and coolant so heat moves flexibly between cabin, motor, and battery. Why does this matter? Efficiency. Most EVs use resistive heating in winter, essentially a toaster element, with 1-to-1 efficiency. A heat pump is different. It moves heat using refrigeration, delivering 3 to 4 watts of heating for every watt of electricity. That's 3 to 4 times more efficient. Real-world data shows EVs with heat pumps retain about 83% of rated range in freezing weather, versus 75% without heat pumps. On a 250-mile EV, that's 207 miles versus 187 miles. 20 miles matters.
The integrated design also enables dynamic prioritization. Fast charging on a hot day? More cooling goes to the battery. Cold morning start? Waste heat from the motor warms the cabin faster without draining the battery. Hit defrost? The evaporator drops the air's dew point for instant clarity. Serviceability is the other major benefit. Traditional HVAC systems have long hose runs and components buried behind dashboards. Diagnosing leaks takes hours. Model 2's thermal block is front-mounted and accessible. One cover, one manifold, straightforward diagnosis. If a valve fails, it's a quick swap, not a multi-hour teardown. Shorter hose runs also mean less total refrigerant, which lowers environmental impact and reduces refill costs. But there's another advantage that becomes critical over time. Fewer joints mean fewer leak points. Traditional automotive AC systems can have 12 to 18 hose connections and O-ring seals. Each one is a potential failure point. Over years of temperature cycling and vibration, refrigerant slowly escapes. You lose cooling capacity gradually without even noticing, until one summer day when the AC barely works. Model 2's integrated manifold reduces those connections to perhaps 6 to 8 critical seals, all designed for long-term durability. The system is more likely to maintain peak performance for 8 to 10 years without refrigerant top-ups. That's $150 to $250 saved in maintenance costs you won't see on a traditional system. The result is a system that heats and cools efficiently, extends winter range by 8 to 10%, fails less often, and costs less to repair when needed. Now, engineering brilliance means nothing if people aren't safe inside the car. And this is where Tesla went beyond efficiency into life-saving technology designed specifically for the moments that matter most.
Proactive, vision-guided airbags. In California, summer cabin temperatures regularly hit 140 to 160 degrees Fahrenheit inside a parked car. If you're over 55, you worry about 3 things more than anyone else: getting trapped if the battery dies, extreme heat cooking you alive, and what happens in a side impact crash when your reaction time isn't what it used to be.
The 2026 Tesla Model 2 fixes all 3 permanently. And it does it with engineering no $60,000 luxury EV can match today.
Let's start with something that could save your life: proactive airbags. Traditional airbag systems wait for accelerometers to detect impact. In a frontal collision, the sequence from detection to full deployment takes 50 to 70 milliseconds. Every component follows a rigid timeline. Accelerometers register sudden deceleration, an electronic control unit processes the signal, pyrotechnic charges ignite, and nitrogen gas inflates the bag. The entire chain reaction happens in less than 1/10 of a second. The Model 2 changes this entirely. It ships with software version 2025.32.3, adding the frontal airbag system enhancement. This uses Tesla vision cameras to see an unavoidable crash before it happens. The car knows you're about to crash 10 to 15 milliseconds sooner than any Mercedes, BMW, or Lexus on the road in 2025. 8 high-resolution cameras analyze closing speeds, trajectory angles, and obstacle size in real time. When impact is unavoidable, the system doesn't wait. It begins prepping immediately, spinning up pumps, commanding valves, pre-tensioning inflation. By the time actual impact registers, the airbag is already halfway deployed. If you're over 50, this matters more. Our bones become more fragile. Our necks can't handle the same forces. A poorly timed airbag can cause harm, but surgical precision deployment reduces head injury risk by an estimated 18 to 22% compared to traditional systems. Tesla Vision doesn't replace accelerometers and pressure sensors. It adds intelligence. The computer fuses camera data with sensor signals and makes the final call. This multi-source approach reduces false positives and cuts decision time. And here's the kicker. This is standard on every Model 2. No extra cost, no options checkbox.
One-touch dual-path door system. Now let's talk about getting trapped inside your car. NHTSA reviewed 174,000 Model Y vehicles from 2021 after 9 complaints about doors not opening with weak auxiliary batteries. 4 cases involved parents breaking windows to free children. One incident in Scottsdale, Arizona, saw a family trapped for nearly 20 minutes in 112-degree heat before emergency services arrived. Another case in Palm Springs required firefighters to use hydraulic tools. That's not user error, that's a design problem. The Model 2 solves it with the one-touch dual-path door system. Inside the cabin, there's a single button within reach. With power, it commands the latch motor electronically. Without power, that exact same button mechanically releases the door using built-in backup. One button, one motion, works every time, battery fully charged or completely dead. Even if the 12-volt auxiliary battery is stone-cold dead, something that still happens on current Teslas in extreme heat, one press inside or one pull outside opens the door mechanically. No broken windows. No waiting 45 minutes for roadside assistance while baking at 140 degrees. Outside, the Model 2 uses a semi-flush handle that's easy to grab. It maintains aerodynamics while adding a direct mechanical path. You simply grab and pull. Does this compromise crash safety? Absolutely not. The handle load path, latch structure, and arbitration logic were redesigned to cooperate, but door retention strength doesn't change. The Model 2 becomes easier to open in emergencies while fully meeting crash safety requirements.
3-stage side impact fortress. California Highway Patrol data shows drivers over 55 are involved in 28% more T-bone collisions than the national average. Intersection crashes represent the highest fatality risk for older drivers. When you're hit from the side, there's maybe 6 to 8 inches between you and the other vehicle. There's no engine block to absorb energy, no long hood to crumple progressively. Just a thin door panel and whatever structure the engineers put behind it. The Model 2 uses a 3-stage side impact absorption system. Stage 1, the door intrusion beam, a thick steel bar that takes the first hit and steers force downward into the side sill. This reinforced box section is stiff but includes tuned crush zones that absorb energy over time, keeping the door from pushing toward your seat. Stage 2, the battery pack perimeter. The outer wall and internal webs act as a second structural member, spreading load down the car's length. Energy-absorbing inserts between sill and pack soften the pulse, turning a sharp blow into a manageable event. Stage 3, floor crossmembers bridge across the floor pan and carry remaining loads to the far side cell. By dispersing energy instead of concentrating it, the Model 2 slows intrusion rate. The result? Cabin intrusion stays under 45 millimeters, less than 2 inches. Most current $50,000 EVs allow 80 to 100 millimeters. That's literally twice as much metal coming toward your ribs. The Model 2 also uses a hot-stamped variable thickness door ring, a rigid belt wrapping the entire door opening. Instead of uniform steel, this uses several hot-stamped sections with different thicknesses laser welded together. Hinge zones are thicker for load. Low stress areas are trimmed for weight. After hot stamping, tensile strength reaches 1,300 to 1,500 megapascals, 3 times stronger than typical car steel. Because this ring is a closed loop, loads split and travel along multiple paths. That means higher torsional stiffness, better lateral intrusion resistance, and a roof far less likely to collapse in rollover. In daily use, doors shut with a bank vault thunk. Panel gaps stay even after years. Seals remain compressed, keeping wind noise low.
Heat rejection package. If you live in California, you know about parking lot heat. You return to your car feeling like you've opened an oven. The steering wheel burns your hands, the seatbelt buckle is too hot to touch, and if you've got dark leather seats, you're sitting on a griddle. Early factory leaks confirm the base Model 2 will not offer a panoramic glass roof in the U.S. market. That's exactly what drivers in California, Arizona, and Texas asked for. Glass roofs look beautiful in showrooms, but they turn your cabin into a greenhouse during summer months. Consumer Reports testing found glass roof vehicles average 12 to 18 degrees hotter than solid roofs after 2 hours in direct sun. Instead, Tesla uses a solid steel roof with a new dual-layer radiant barrier underneath, like a space blanket built into the ceiling, reflecting infrared heat before it reaches the cabin. This aerospace-grade material was originally developed for spacecraft thermal protection and reflects up to 97% of radiant heat. The outer layer blocks solar radiation, while the inner layer creates an insulating air gap that prevents heat transfer into the headliner. Combined with new light gray vegan leather that reflects 42% more heat than black interiors, parked cabin temperature drops an average of 18 to 22 degrees Fahrenheit compared to a current Model 3 with glass roof. Instead of 155 degrees, you're looking at 133 to 137 degrees. Still hot, but the difference between unbearable and manageable. More importantly, it's the difference between heat exhaustion risk and simple discomfort for anyone over 60. When you turn on climate control remotely from your phone, the cabin cools in half the time because there's less thermal mass to overcome.
The 10-year ownership equation. Let's connect everything. Let's connect everything. Model 2 uses aluminum batteries that last 10,000 plus cycles. A unibody frame built in 90 seconds by a 50,000-ton press. An AI-5 chip that learns and evolves. Bolt-on crash pods that turn collision repairs into module swaps. Unpainted cladding that protects resale value. A sealed underbody that defeats corrosion. A 48-volt electrical backbone that eliminates gremlins. An all-in-one Hvac system that extends winter range by 8% to 10%. Proactive airbags that see crashes before they happen. A one-touch door system that works when the battery is dead. And a 3-stage side impact fortress that limits cabin intrusion to under 2 inches. Over 10 years, fewer electrical faults will save you $500 to $1,200. Simpler HVAC service will save you $300 to $800. Better winter efficiency will save you $400 to $600 in charging costs, and reduced refrigerant maintenance will save you $150 to $250. Modular repairs, $1,500 to $3,000 saved. Lower insurance premiums, $300 to $600 per year. Total potential savings are $2,850 to $5,850 compared to traditional EVs in the same price range. That's the difference between affordable and truly cost-effective. Now think about this in the context of the used car market. Most buyers shopping for a 5 or 7-year-old EV are terrified of battery replacement costs and unpredictable repair bills. But a Model 2 with documented low maintenance costs, a clean Carfax, and proven winter range retention, that vehicle will hold resale value better than anything else in its class. Every revolution starts with a spark, but this one feels different. Tesla didn't just build a cheaper car. It built the blueprint for how machines will think, build, and evolve on their own. We're standing on the edge of something bigger than cars, a future where intelligence isn't designed, it's discovered. Maybe that's what Musk is really building. Not cars, not factories, but a new kind of relationship between humans and machines. Every Tesla becomes a teacher, and every driver a student of the future. The road ahead isn't just asphalt, it's a living network of learning. Each turn, each mile, another conversation between intelligence and intention. The Model 2 doesn't just move us forward, it reminds us what evolution feels like. And here's what I want to know from you. When you imagine that world, what do you hope it looks like? A future where technology serves humanity, or one where they finally become the same thing? Drop your thoughts below. I read every comment. Because if you've made it this far, you're already part of that story. The one where technology doesn't just move us, it defines us. Hit subscribe to stay ahead of what's next, because the next chapter isn't about batteries or frames anymore. It's about the AI 5 chip that may soon link Tesla's mind to the sky itself. I'll see you in the next one.